Hello everyone, this is Hating Tian. This video, let's learn dot product vectors in space, cross product. Let's see the dot product first. The definition is if the vector v is equal to a sub 1i plus b sub 1j, w is equal to a sub 2i plus b sub 2j. So the dot product is defined as v dot w is equal to a sub 1 times a sub 2. The product of the I component or x component plus b sub 1 times b sub 2. Okay, before we move on, so what is the physical definition of the dot product? For example, if I have the xy plane, I have two vectors. The first vector we call the v, and the second vector we call it w. So if I'm looking for v dot w, I'm using my second vector. So do the projection on the v. So draw a perpendicular line to the v. So the distance from here to here is, let's say, put an a here. So this is a projection of the w to the v. So what is the magnitude of the v? Let's say is b. A and b here, they are the constant number. They are scalars. It's not a vector. So v dot w is equal to a times b, the projection, the length of the projection, and multiplied by the magnitude of the v. So a times b is number times number, is also a number. So the dot product is scalar. So dot product is a scalar and not a vector. Scalar is a number. Okay, let's see the first example. I have two vectors. V is 2i plus 3j. W is 4i minus 7j. Find the v dot w. So v dot w is equal to 2 times 4 plus 3 times negative 7. And we have 8 minus 21, which is negative 13. So this is a dot product. Property of dot product. If I have the v dot itself, v dot v is equal to the magnitude of v squared. So let's memorize this. You can highlight this. So the dot product can be used to find the angle between two vectors. So cosine theta, the theta is the angle between the vector u and the vector v. Cosine theta is equal to u dot v divided by magnitude of v times magnitude of u, where theta is between 0 and 180 degree. So theta cannot be a negative number, cannot be an angle is greater than 180, because if I have two vectors, so I have one case. First one, these two vectors, they overlap to each other, and the angle between them is 0. That's the smallest angle. So I should have a degree symbol here. And how about I move my, so this is v, let's say this is w, the short one. I can rotate my w, we can make a theta, and if I have the angle here, that's perpendicular, and I rotate here, here. So if I have the vector here, that means the angle is 180 degree. If I keep rotating, I'm going to have my vector here. So the angle between these two vectors is the angle here, is the theta. I cannot say it's a counterclockwise rotation from one to another. No, just the angle between these two vectors. So the vector is between 0 and 180 degree. Okay, let's move on. So example 2, find the angle between the given vector. So what is the formula? So we have the formula here. We can highlight them. What do I need if I'm looking for the theta? I need to find the dot product between u and v and the magnitude of u and v. So let's put the let's find the u dot v. U dot v is equal to 2 times 4 plus 3 times negative 7. Oh, this is a previous example. This is negative 13. And then find the magnitude of u and magnitude of v. Magnitude of, oh, my bad. This is w. Because you see the notation is w. Okay, magnitude of u. Where is u? This is v. Because you see here is v and w. Even it looks very similar like the previous example, but it's changed the name of the vector. Let's put the v here. Magnitude of v is equal to square root of 2 squared plus 3 squared. It is 4 plus 9 is square root of 13. And then find the magnitude of w. This time I didn't make a mistake. So it's equal to 4 squared plus negative 7 squared is equal to 16 plus 49 is 65, square root of 65. Now, let's list the equation. So cosine theta is an angle between the v and w is equal to dot product. So we can make it short. V dot w divided by magnitude of v multiplied by magnitude of w. And plug in all the information. We have negative 13 divided by square root of 13 times square root of 65. And we don't have to simplify this. I just want to find the inverse. So let's find the cosine, or we can find the inverse of cosine. Negative 13 divided by square root of 13 times square root of 65. So let's use our calculator to do the computation. So let's clear. Second, cosine on the top is negative 13 divided by parentheses because the bottom has 2 square root. So square root, square root of 13 multiplied by square root of 65. And move the cursor. Okay. Close the parentheses, hit enter. So we're going to have 116560505. So let's round it to 2 or 3 decimal places. Okay, it's about 116.565 degree. So that means the angle between these two vectors is 116.565 degree. So you don't need to worry about where is my angle, in which quadrant, first, second, third, or fourth. So because the inverse cosine is in these two quadrants, and also our theta is between 0 and 180 degree. That means if is in these two quadrants, find the inverse of cosine. And that is the theta's value bounced between 0 and 180 degree. Okay, so do I have to graph it? Yes, maybe if you like, you can graph it. First, I can find my v and w. So let's see, we have y is negative 7. So let's see, draw a horizontal line. So let's say this is our x-axis. And then draw a vertical line, say this is the y-axis. Okay, so first let's find the v. V is 2, 3. So 2, 3, the terminal point also is 2, 3. So it's from initial to terminal is here. This is my v. And the w is 4, negative 7. 1, 2, 3, 4. And go down 7 units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 is here. Okay, let's connect them. Okay, so the angle theta is 116.565. You don't have to graph it if the question didn't ask you to graph. But by the graph, you can tell that your theta is an obtuse angle, is more than 90 degree. Okay, let's move on to see next example. It gives us the xy plane. Maybe we can graph it. But let's see, determine two vectors are parallel or not. What's the meaning of parallel? So if I have a vector v and I have another vector w, they overlap to each other. I can say these two, they are parallel to each other because I know that the vector v and the vector w can be moved so they can be moved parallelly. So I can move the w to here. If they are parallel, that means they are overlap to each other. And how about these two vectors? They have the opposite directions. So this is the v, and then this is w. I moved the w to here. Okay, this is an initial point. They are also parallel to each other if they have the opposite direction. So let's clear the area here. I want to see if these two vectors are parallel to each other or not. Let me ask you, if two vectors, they're overlap to each other, what is the angle between them? So theta must be 0 if it's parallel to each other. And how about they are opposite to each other? So the angle between them is 180 degree. So theta is equal to 180 or 0 degree. So these two vectors, they are parallel to each other. So in what case? I already introduced the two cases. So cosine 0 equals what? Equals 1. How about cosine 180 degree? It's equal to -1. So if I can list the equation between the angle theta and the v and w, dot w divided by magnitude of v times magnitude of w, I see the value is equal to positive or -1. That means these two these two vectors they are parallel to each other. Let's do the evaluation. So let's erase this. What is the cosine theta? If it's 1 or -1, they're parallel to each other. Cosine theta is equal to dot product between v and w. So before that, let's find the dot product and then plug it into the formula. So v dot w is equal to 3 times 6 plus -1 times -2. So is 18 plus 2 is 20. So v dot w is 20. And we are looking for the absolute value of v and the absolute value of w. My bad. The magnitude of v and the magnitude of w. Magnitude of v is 3 squared plus -1 squared, which is square root of 10. And the magnitude of w is equal to square root of 6 squared plus -2 squared, which is square root of 40. So the cosine, how did I change the color? So cosine theta is equal to the 20 over square root of 10 times square root of 40. So let me ask you, what is the denominator? I have learned the product rule. I can combine these two together. So by combining them, I have 1 square root, which is 10 times 40. The bottom is 20, and so bottom is square root of 400. So square root of 400 is 20. 20 over 20, it is 1. That is my first case. So theta is equal to 0. They have the same direction, and the angle between them is 0. We can also graph it. For example, find the vector 3 I minus j. So let's let's see how to graph it. Assume this is my x-axis, and then this is my y-axis. And the first vector is 3, comma, -1. 3, comma, -1 is here. And the second vector is 6, comma, -2. So let's find 6, comma, -2 is here. Okay, you see we have two vectors, they overlapped. And the angle between them is 0. Okay, 0 degree. So I say V is parallel to the W. So these two vectors, they are parallel to each other. So we'll use this symbol, represent the parallel. So then let's see next one, how to determine if two vectors are orthogonal. What is the meaning of orthogonal? If I have vector V, vector W, and the angle between them is 90 degrees. So this is orthogonal. And for the cosine 90 degree, what is the value of cosine 90 degree? 0, right? Okay. And how about this? Cosine theta is equal to u dot v divided by magnitude of v times magnitude of u. So the bottom is, so this one I know that is magnitude. This one is magnitude. So this should be a number times another number. Only if the top is 0 divided by the magnitude, the multiplication between the magnitude is 0. So I can just evaluate my u dot v is 0. Then I can tell my angle between these two vectors is 90 degree, which means orthogonal. So two vectors are orthogonal. So then I want to, so I can do the conclusion. If V is orthogonal to, so let's say, keep the order because U goes first. U is orthogonal to V. Then I can tell that U dot V, the top of the fraction must be 0. Okay, let's see the first example 4. Determine if the two vectors are orthogonal. Okay, so we have two vectors. If I'm not drawing it, I want to find if v dot w is 0. V dot w is 2 times 3 plus -1 times positive 6. So is 6 minus 6, which is 0. Yes, because I have cosine theta is equal to 0. I didn't do the computation about the magnitude. So 0 divided by the question mark, which is non-zero things. So it is 0. So cosine 90 is equal to 0. That means they are orthogonal to each other. But I don't have to repeat this. I just say, if I can say the dot product is 0, so V is orthogonal to W. I can also verify from the xy plane. So let's find what is the vector 2i minus j, vector v and vector w. So let's draw a line. This is my x-axis, and where is a line? This is x-axis. X-axis. So let's see, what is the problem? Let's use this. So this is the x-axis. I think there is a problem, so I will fix a problem. And don't worry, if you have time, you can draw these two vectors, and you can tell that they are orthogonal to each other. For example, if I have 2i minus 1, so 2i negative 1, I'm going to have this. So this is my vector, and 3, they have the same initial point. 3, positive 6, 3, 6, 6. So 3, negative 6, you can tell is a vector like this. That means these two can be told is orthogonal from the graph. So let me stop. We learned the vectors in two-dimensional, so it's just the vector on the plane, but now the vector popped from the two-dimensional. So let's talk about vector in space. This vector can be moved in the space. So find the distance between the 2 points in the space. So if I have 2 points, they are on the two-dimensional. We say this is x sub 1, y sub 1, and x sub 2, y sub 2. Finding the distance is equal to square root of the difference of the x sub 2 minus x sub 1. So very bad drawing. Make it prettier. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So how about two-dimensional? It also has a z coordinate. We do the same thing. We have the formula, which is the distance is square root of the difference of the x squared plus difference of the y squared plus the difference of the z squared. For example, if I'm looking for the distance between the 2 points in three-dimensional, the distance is equal to square root of the difference of the x. Use the second x minus first x. 4 minus negative 2, and then square it. Plus the difference of the y, 3 minus 2. Use this 3 minus this 2. I'm going to have a 3 minus 2 squared. Plus negative 3 minus 3, all of them squared. I can do the computation. So what is that? So is 4 plus 2 squared is 6 squared plus 1 squared plus 6 squared. What is that? Is 73 squared. Square root of 73, because 36 plus 36 plus 1 is 33. Square root of 33. The distance between the 2 points is square root of 33. Okay, suppose that V is a vector with the initial point P sub 1 is equal to x sub 1, y sub 1, z sub 1. And the terminal point is P sub 2 is equal to, x sub 2, y sub 2, z sub 2. If the V is a vector starting from P sub 1 to P sub 2, then V is equal to the position vector. So if I have 2 points, you can find the position vector, which is V sub V is the vector from P sub 1 to P sub 2. And the V is x sub 2 minus x sub 1 I plus y sub 2 minus y sub 1 j plus z sub 2 minus z sub 1 k. Use a terminal minus initial. Okay, it's similar like the two-dimensional vector. Find the position vector of the vector v. So given 2 points, so the v is equal to, I can solve the v in the ijk form or in the component form. So x-axis, y-axis, and z-axis. So the x-axis is the difference between the x, use the second x, 4 minus negative 2, comma 3, comma 3 minus 2, and then comma negative 3 minus 3. So let's do the computation. It is 6, 1, negative 6. And in the ijk form, v is equal to 6i plus 1j minus 6k. Okay, let's move on. So find the magnitude of the vector in space. If v is a comma b comma c, the magnitude of the vector is the length or the distance of the directed line segment. So this is similar like the 2D. So is the distance or the length. The magnitude is defined to be magnitude of v is square root of a squared. So x component squared plus b component squared plus c component squared. Find the magnitude of v. See the previous example. So we already found the v is 6, 1, -6. So finding the magnitude is easy. Just plug in the ABC's value in the formula. So which is 6 squared plus 1 squared plus -6 squared. I think I did this computation. So it is square root of 73. Why I said I did this? Oh, that is the meaning of the distance between the 2 points, and also means the distance or the magnitude of the vector. Okay, find the dot product of the vector in space. If the two vectors are given, so v and u, so the dot product is defined as, so a sub 1 times a sub 2. So this a sub 1 times a sub 2 plus b sub 1 times b sub 2 plus c sub 1 times c sub 2. So the dot product is a scalar. Not vector. Also, that means the projection multiplied by another magnitude of another vector. So give two vectors, find v dot u. So v dot u is equal to the 2 times 1 plus -2 times +1. It's very messy. Let's do this. 2 times 1 plus -2 times 3 plus 1 times -4. Let's do the computation. Is 2 minus 6 minus 4 is -8. So find the angle between two vectors in space. So in two-dimensional, we have learned finding the angle between two vectors. We have a formula which is cosine theta is equal to u dot v divided by magnitude of v times magnitude of u, where the angle is between 0 and 180 degree. Now for the vector in three-dimensional, we have the same thing. So we need to find the angle. First, we need to find what is the dot product and also find the magnitudes. And also here, I will remind you, if I have u dot v, it's the same thing like v dot u. So you switch the position, you have the same number. And also this is a scalar. Okay. Let's see, find the angle between v and u. So review this. If the cosine theta is positive or -1, we have two vectors parallel to each other. And if I have the cosine theta is 0, then v is orthogonal to u. Also, this one represents the u dot v is 0. That means two vectors are orthogonal to each other. Let's find the angle between v and u. So the v angle between v and u has a formula. So we need to find the u dot v. But what is the v? So we can put the v here. So v is the previous example. V and u's v and u vector are on the top. It is in the component form, which is 2, -2, 1. And the v is, u is is 1, 3, -4. Okay, how about u dot v? U dot v is equal to v dot u. We have found this from the previous example. It's -8. So next step is find the magnitude of v. Magnitude of v is 2 squared plus -2 squared plus 1 squared. It is square root of 9. Square root of 9, which is 3. What is the magnitude of u? Magnitude of u is equal to square root of 1 squared plus 3 squared plus -4 squared. It is square root of, so let's see if I can find it easily. 1 plus 9, 10. 10 plus 16, 26 is square root of 26. Okay, this one I cannot simplify, so we keep this solution. How about cosine theta? Cosine theta is equal to -8. That's the dot product divided by 3 times square root of 26. And finding the theta, just find the inverse of cosine. -8 over 3 times root 26. This must be an obtuse angle because negative value. So let's input this in the calculator. So let's find second cosine. I think on the top is -8. Is that -8? Very bad memory. Yes. -8 divided by 3 square root of 26 divided by 3 times square root of 26, and then close the parentheses, close the parentheses. The angle is 1 to 1.53 degree if I keep 2 decimal places. So the angle is 1 to 1.53 degree. Okay. If it's in the reading measure, you can change your calculator in the reading measure. Let's see, find the unit vector. It has the same formula to find the unit vector. The unit vector has the length or magnitude of 1, and it will have the same direction of my vector v or vector. Okay, for example, if I have a vector and I move it to the position initial point, here is the position vector v, and the magnitude, for example, is 2, and its unit vector has the same direction, but it has the magnitude must be 1. So this one we call the unit vector of v. So u here is another vector, and this vector has a name, is unit vector. Length is 1. And for the unit vector is equal to v, the vector v divided by its magnitude. It will keep the same direction, but the length must be 1. Okay, for the first example, find the unit vector in the direction of v is 9i plus 3j minus k. So unit vector u is equal to, so I prefer to have the component form, which is 9, 3, -1, all divided by magnitude of v. What is the magnitude of v? Is equal to square root of 9 squared plus 3 squared plus -1 squared. So let's do the simplification. It's 81 plus 9, 90. 90 plus 1 is 91. Square root of 91. So the bottom is square root of 91. And every component divided by square root of 91. So unit vector is 9 divided by square root of 91. 3 divided by square root of 91, and the -1 over square root of 91. You can also convert it to the IJK form, which is 9 over root 91 I plus 3 over root 91 j minus 1 over square root of 91k. Okay, let's see. Oh, last one, you try. Given vector v is 3, -4, -1, find unit vector. So finding the unit vector, I need to find the magnitude of v. So magnitude of v is equal to square root of 3 squared plus -4 squared plus -1 squared. So let's do the computation. It is 9 plus 9 plus 16 plus 1 is 26. Square root of 26. So the unit vector, so let's put it here. U is equal to v over magnitude of v. This is every component divided by square root of 26. 3 divided by square root of 26, comma, -4 divided by square root of 26, comma, -1 over square root of 26. Let's see cross product. The cross product is a vector that is orthogonal to the plane v and u. So two vectors v and u can construct a plane. You see the yellow part is that plane. The cross product u cross v is a vector which is perpendicular to this plane. How to decide my cross product directions? So I'm going to use the right hand rule. So let's see this image. So this is right hand rule. So if I have two vectors, vector A and vector B, looking for the A cross B. So I'm using my right hand. Pull out your right hand. The A is the first vector is A, which is my index finger. My second vector B is my middle finger. And then lift up your thumb. So your thumb is the direction of the cross product, which is A cross B. And how about if I if I flip the A and B, I say B cross A. That means I need to flip my hand. So try this. Flip your hand and then use your index finger, point to the B direction because B is the first vector. And use your middle finger, point to the A. You will find that your cross product is pointing down or the opposite direction of the A cross B. Okay, let's come back to the lecture notes. So the definition, if I have two vectors, so the vector A, V and the vector U, so the cross product, V cross U, we're having a formula. But I'm not going to ask you to memorize this formula. We can use an easy method to find the cross product. So make sure that your cross product is a vector. And let's review the dot product. Dot product is a scalar, is a number, but here is a vector. So before we find how to before we start to find our cross product, let me introduce a definition, or we say this new definition is determinant. So what is a determinant of a matrix? For example, I have matrix A, B, C, D. This is matrix. So when I box the matrix, I'm using a two straight line. So I'm using these two straight line. That means I'm looking for the determinant of this matrix. So in college algebra, we have learned matrix. And so if I pull out the horizontal line A, B, so we say A, B, it is a vector A, comma B. And another vector CD, for example, this is a vector CD. And then the determinant of this matrix means find the area of this parallelogram. So find the area of this. And if you change the position of the two vectors, you will get the opposite determinant, or the negative. For example, this is positive 5, and if you change the direction, you have the CD and AB. The determinant to change it to the negative 5. It doesn't mean the area is negative 5. That means positive 5 is a direction or positive direction, and the area value is negative 5. That means I change or flip my orientation. Okay, I will attach the video, video link in this video, so you can check the physical meaning of the determinant. So let's move on. Let's clear space. Okay, how to find the value of a determinant? We will do the cross multiplication. So starting from the top, starting from the A, and we are going down. So A multiplied by D, then minus C times B. So this is, this is down minus up. So follow the direction I have pointed here, which is A times D minus C times B. Okay, so let's move on to next part. What's the relationship between the cross product and the determinant? For example, if I have two vectors, V is equal to A sub 1, B sub 1, C sub 1. And the V is equal to, okay, let's change. So let's say this is U. And this is V. It's A sub 2, B sub 2, and C sub 2. So you remember that if I write them in the IJK form, which is A sub 2i plus B sub 2j plus C sub 2k, but I'm not writing it in that form. So for the I part, so the I position, component, so we are going to have A sub 1, A sub 2. For the J position, we are going to, component, we say B sub 1, B sub 2. For the K component, it is C sub 1, C sub 2. And looking for the cross product, we say U cross V. It is equal to, first, this one must be a vector. Vector need to have the I, J, and the K part. But in front of the I, J, K, I don't know what are they. Let's figure out what are they. So the first one is the determinant of a square matrix multiplied by I. And then, second is minus. So let's memorize that. The first one is positive. You can ignore this positive. Next term must be minus. Minus what? Minus determinant of a squared matrix multiplied by J. Then plus. So next one is plus. We're going to have a alternative sign. So positive, negative. Another determinant multiplied by K. So what should I put inside of this determinant sign? So we are going to come back to here. So let's use different color. Box it. Let's box this part. So first, in the first determinant sign, we're going to have these four information, B sub 1, B sub 2, C sub 1, C sub 2. You can ignore the vertical line of the I and ignore the horizontal line of the I. Then you have the leftover B sub 1, B sub 2, C sub 1, C sub 2 vertically. And also you need to multiply by I. So let's put them here. They are B sub 1, C sub 1, B sub 2, C sub 2. And for the second determinant, what should I do? I should let's clean this. So I'm highlighting the A sub 1, A sub 2, C sub 1, C sub 2. I should ignore the horizontal line of J and the vertical line of the J because I'm multiplying by a J here. So I should put A sub 1, A sub 2, C sub 1, C sub 2, and plus the determinant of another matrix. So I shouldn't make it here that messy. So let me clear and then fill out the blanks here, which is A sub 1, A sub 2, C sub 1, C sub 2. And the last determinant, it is, so let's clear the highlighting place. So now what should I do? I should cross out the K horizontal line or the K vertical line. Now I can see the four leftovers. So fill out the blank, fill out the determinant. So A sub 1, A sub 2, B sub 1, B sub 2. Now let's see, what is the determinant? We do the cross product. This is a positive. We are going to have the direction down minus up, down minus up, down minus up. So we're going to have B sub 1 times C sub 2 minus B sub 2 times C sub 1, I. Then minus A sub 1, C sub 2 minus A sub 2, C sub 1 times J plus A sub 1, B sub 2 minus A sub 2, B sub 1, K. Okay, did you see something? We use this method, conclude our formula here. So I do not suggest you to use the formula. I suggest you to expand it into the determinant multiplied by the ijk. And the three important part is the sign. So positive, negative, positive. The first positive can be eliminated. Okay, let's move on. Let's see. Given two vectors, find the cross product V cross W. Okay, we can first list the ijk component. So ijk. So for the V, so V is the first vector in the cross product. So let's list the V. V is -1, 3, 2. So these are my A sub 1, B sub 1, C sub 1. And how about W is 3, -2, -1. Now we are looking for V cross W is equal to positive the determinant times I minus determinant times J plus determinant times K. So let's fill out the blanks. First, let's use this color. I need to highlight the four numbers here because I can cross out the horizontal line of I, cross out the horizontal line of the J of the I. Horizontal line of the I, vertical line of the I, because I is here. I don't have to keep all of the I horizontal and vertically. So what should I put inside? Okay, it is positive 3, negative 2, 2, negative 1. And how about next determinant? We can use different color. So which line I need to cross out? So this is J. So horizontal line of J, horizontal line, vertical line of the J. So we can use the red color to highlight the rest of the 4 number. So in your homework or on your exam, you can use your finger to cover the vertical line of the J and the horizontal line of the J. Then you can find the 4 numbers. Okay, let's make it clear. We can erase the marker, so make it clear. So we are going to have 4 numbers, which is negative 1, 2, 3, negative 1. And the last one is cross out the K horizontally and vertically. So these 4 numbers, they are negative 1, 3, 3, negative 2. Let me check if I have any mistake. I think no mistake. And then we need to evaluate the determinant and then multiply by I, J, and K. So let's do the cross multiplication down, up. So down, up, down, up. If you feel it's so messy, you don't have to graph the down, up arrows. So let's see. Parentheses 3 times negative 1 minus negative 2 times positive 2, brackets I. And then minus, let's use brackets, negative 1 times negative 1. So up, down. Minus 3 times 2, J, plus brackets negative 1 times negative 2 minus 3 times 3 go up. This is K. Let's do the computation. In the bracket, we have negative 3 plus 4. So this is positive 1. So it is 1I. And then in the brackets, we have this is positive 1 minus 5 is negative 4. So, what are they? So this is positive 1 minus 6 is negative 5. So minus negative 5, J, and then plus what? In the brackets, we have positive 2 minus 9 is negative 7. So negative 7, K. So let's simplify the expression. We're going to have I plus 5J minus 7K. So we found the cross product, V cross W. It is a vector. Okay, let's see next example. If I have 2 vectors, so U and V, another vector is W. We have, 3 vectors. We are looking for U cross V, and then all of them dot W. So we have cross product and dot product. Let's see what is the solution. First, in the parentheses, the computation goes first. So U cross V is a vector. Vector dot another vector, dot product. It is a scalar. That means the solution must be a scalar. Is a number, positive or negative number. So let's do the parentheses first. So if I want to find the cross product, what should I do? I can highlight my U and V. So first step, I can list the IJK component vertically. So IJK. So for the U, we have 2, negative 3, and the positive 1. And for the V, we have negative 3, positive 3, and 2. So let's see, 2, negative 3, 1. Negative 3, positive 3, 2. Now let's do the cross product. So U cross V, is equal to positive determinant times I minus determinant of square matrix times J plus determinant times K. So let's fill out the three determinant by using the square matrix. So first, remove the I horizontal vertical line. So we're having -3, 3, 1, 2. And the second one, cross out these two, we're going to have 2, -3, 1, 2. And for the last one, cross out the K horizontal vertically. So 2, -3, -3, 3. Okay, let's find the determinant and find the cross product. So down, up, down, up. I can draw a first direction. Down, up, down, up. -3 times 2 minus 3 times 1. Brackets I minus down, up, 2 times 2 minus -3 times 1. Brackets J plus down, up. We have 2 times 3 minus -3 times -3. Okay, let's see, what are these? So in the bracket, we have -6 minus 3 is -9i. And then second bracket, we have 4 plus 3. 4 plus 3 is 7 minus 7. J, then plus what? In the parentheses, we're having, okay, let me pause the video. The last bracket, we have 6 minus 9. 6 minus 9 is -3, -3k. So simplify the last term, we have -9i minus 7j minus 3k. All of them, they are negative. And let's see what is the dot product between the vector u cross v and dot w. That means I'm using my -9i minus, if I'm using the component for -9, comma -7, comma -3, dot what? Dot w. W is 1, 1, 3. So we're using a sub 1 times a sub 2 plus b sub 1 times b sub 2 plus c sub 1 times c sub 2. So -9 times 1 plus -7 times 1 plus -3 times 3. Okay, let's do the computation. We're having -9 minus 7 minus 9. So we have -18 minus -7, which is -25. So solution is -25. Okay, that's the last question? Yes, that's the last question of 3.2. Have a good one. It's disappeared. So you can find the lecture notes in D2L. I post the lecture notes in D2L. And if you pause the video maybe 10 seconds before, you can find the solution.